For centuries, humanity has stared into night sky, asking the same questions. How far does the universe go? How small are we, really? And is there a limit to what we can discover? But now a new response has emerged. And it didn't come from a dream or a myth, but from the most powerful space telescope ever built, the James Webb Space Telescope, floating nearly 1 million miles from Earth, just sent back data so remarkable, so perplexing, that it's forcing scientists around the globe to rewrite our preconceived notions about the scale of everything. Galaxies where there ought to be nothing. Black holes forming when the universe was just a baby. Dust clouds giving birth to stars we can now watch grow. And that's just the beginning. Because with one simple observation, Webb didn't just expand the known universe. It revealed a secret too vast, too complex, too deep for even our boldest minds to imagine. And the implications? They might just change our place in the cosmos forever. The James Webb Telescope was never meant to just replace Hubble. It was engineered to be something far greater. A machine capable of reaching the very first light after the Big Bang, with a mirror 6 times larger than Hubble's, and precision instruments that see in infrared, allowing it to pierce through the cosmic dust that hides the birth of stars and galaxies. Webb was built to look back not just millions, but billions of years into the past. And that's precisely what it did. When the first images arrived, scientists were stunned. The darkness of the sky wasn't dark at all. Where we once saw faint smudges, Webb revealed galactic oceans, each with billions of stars, planets, and perhaps life. But what was truly terrifying wasn't the quantity. It was the timeline. Webb found complex galaxies, spirals, bulges, even traces of dust, in a universe that was supposed to still be forming. These galaxies were only a few 100 million years old, yet they showed levels of organization and maturity that defied everything our models predicted. How could this be? Either the universe evolved much faster than we thought, or we're missing something far more fundamental. Musical note music. As the telescope increased its focus on space, it began to reveal the vast scaffolding of the cosmos, an invisible web made of dark matter and gas stretching across billions of light years. Some regions of space, once thought to be completely empty, turned out to be teeming with galaxies, forming patterns that defied randomness. They were connected by filaments of gas, cosmic highways that channel matter and energy across the universe. Webb wasn't just imaging these structures. It was measuring them. Using its spectroscopic tools, it began analyzing the chemistry of distant galaxies, the temperature of intergalactic gas, and even the fingerprints of life-forming molecules suspended in the coldest corners of the void. What emerged was a portrait of a universe far older, far more active, and far less isolated than we ever imagined. Entire galaxies were feeding, merging, and colliding with each other, not in cosmic catastrophes, but as part of an elegant, chaotic dance that has shaped the universe since its birth. And amidst that chaos, one thing became clear. The universe wasn't built in silence. It was forged in fire. Musical note, music. What makes Webb so unique isn't just how far it sees. It's how long it watches. For the first time, we're witnessing continuous cosmic evolution. Webb's long-duration observations of galaxies and stars have shown us things no human has ever seen before. Stars being born, dying, collapsing into black holes, or exploding in supernovas. In distant galaxies, we're tracking light from stars that flared up billions of years ago and faded long before Earth even formed. And yet, we're watching them now. But the real shock came when Webb began to detect exoplanets and their atmospheres. Using a method known as transit spectroscopy, light was captured as it passed through these alien world skies. And in that light it found signs. Water vapor, methane, carbon dioxide, even complex molecules that on Earth are considered the building blocks of life. It wasn't proof of aliens, but it was something perhaps even more powerful. Proof that the ingredients for life may be common, scattered throughout the universe like seeds waiting to grow. But the telescope didn't stop at the stars or the planets. It turned its gaze toward the intergalactic medium, the vast spaces between galaxies that had long been thought to be empty. They weren't. Webb found that these voids were filled with gases, elements, and even free-floating planets. Orphans drifting through the space without any ties, lost in the cold shadows of the cosmos. These rogue worlds weren't anomalies. They were numerous, and their existence shattered our theories of planet formation. Webb also found that galaxies weren't passive structures. They were alive, consuming matter from filaments, pushing out gas through explosions, reshaping their own structures over time. The universe was no longer a collection of individual locations. It was a cosmic ecosystem, a self-sustaining, ever-evolving organism. And Earth? Just a grain of dust floating in one filament, in one galaxy in a tiny spot on a painting. We no longer have enough numbers to enumerate it. Uncovered by the James Webb Telescope, increasingly structured galaxies in the early universe, and its chemical makeup that mirrored those found near Earth, a still hum began to echo throughout online scientific communities and communities alike. Are we in a simulation? It sounds like science fiction, but the implications of Webb's discoveries are pushing even most grounded scientists to re-examine philosophical questions that have long been dismissed as fringe. The mathematical precision of cosmic structures, the rapid formation of galaxies, the uniformity of physical laws across billions of light years. Everything is too arranged. Quantum physicists have long wrestled with the notion that our reality might be a projection from something deeper, something more fundamental. And now, Webb's data, showing how even the farthest corners of the universe follow the same enigmatic patterns, is reigniting that debate with fresh, unsettling energy. Could the universe be a huge simulation running on a cosmic mainframe? The internet might be the first tool capable of peeking behind the curtain. It was during one of Webb's ultra-deep field scans that a strange anomaly emerged in a faraway part of the cosmos, far beyond what any human eye had ever observed. The telescope recorded a set of constant signals embedded in the light from a cluster of galaxies. At first, they were thought to be data glitches, but after weeks of verification and numerous scans, it became irrefutable. The signals were real and non-random. Scientists don't know what to call them. They aren't natural radio bursts. They don't match any known cosmic phenomenon. They pulse at intervals that seem to carry information. Might it be an advanced civilization, an echo of the universe from the Big Bang, or something we don't even have the language to describe? No one knows. But one thing is certain. Something out there is talking, and Webb is the first to listen. Webb's observations have also challenged our comprehension of dark matter and dark energy, the invisible forces that make up over 95% of the universe. By mapping the subtle distortions in light from distant galaxies, Webb has begun to trace the gravitational fingerprints of dark matter in more detail than ever before. And what it found is deeply unsettling. Dark matter does not appear to behave consistently. In some regions, it clumps as expected. In others, it propagates like a fog. Moreover, dark energy, the mysterious force accelerating the universe's expansion, might not be a constant at all. This throws our entire model of the universe into question. What if we've been measuring the wrong things? What if time, gravity, and even reality itself are emergent properties, not universal constants? Webb isn't just showing us a bigger universe. It's showing us that we never really understood it to begin with. One of the lesser-known missions of the telescope is perhaps its most profound: the search for biosignatures, chemical hints that point to life. Webb has already scanned the atmospheres of numerous exoplanets and discovered organic molecules, water vapor, and carbon dioxide. But recently, it made an even more shocking spectral discovery: a dimethyl sulfide fingerprint, a compound on Earth associated exclusively with living organisms. It was found on a planet orbiting a red dwarf 120 light-years away. While caution remains high, it is not yet evidence of life. It is the closest we've ever come to detecting a life signature outside our solar system. If confirmed, this would mark the single greatest discovery in human history, and it would mean we're no longer alone. Life, in some form, exists beyond Earth, and Webb was a telescope that found its breath in the stars. The James Webb Space Telescope was built to answer our deepest questions, but the effect it has had is much more significant. It has shattered our assumptions and rewritten the boundaries of human knowledge, from galaxies where none should exist, to signals that seem to defy the laws of physics, from dark matter behaving in chaotic, unpredictable ways, to organic molecules whispering of life on distant worlds. Webb has done more than show us the universe. It has forced us to rethink our position within it. And perhaps that's a real discovery, not a molecule or planet, but the unsettling realization that we've only just begun to understand the canvas we're painted on. That beyond every revelation lies 1,000 more questions. So, as the telescope keeps looking further into space and further back in time, one thing becomes certain. We are no longer the same civilization that launched this mirror into the void. We are explorers now, not just of stars, but of truth. Because when the James Webb Telescope stares into the darkness, the universe stares back.